missing sides in those triangles, and I'm going to relate it to the special right triangles. So remember how we set up proportions to find the missing sides? 3, 4, 5, 5, 12, 13. We can do the same thing with the special right triangles we talked about yesterday. All right, so we talked about 2 yesterday. This class, I think I started with the 30, 60, 90, right? Okay, so if I draw a 30, 60, 90, there's 3 sides. There's the side that's opposite the 30-degree angle. There's the side that's opposite the 60-degree angle. And there's the side that's opposite the 90-degree angle. What is the ratio of the 3 sides in that triangle? Let's go small to big. What's the ratio of the sides? Hi, greetings. Geometry, we're starting. Notebooks. Phones put away. I am, I'm sorry. I'm getting them out.
No, I did. I'm getting them out. I'm getting them out.
Oh, you're getting them out. Oh. Oh, that's empty. You need to refill it. Weird. I don't know. Cookies? Is that from Karen's English teacher?
I literally bring
No?
cookies every day.
Those aren't the same ones? All right, Josh, go ahead.
So big. You're like this.
I think we gave people enough time to get ready. Yes? Instead of getting ready when the bell rings and being ready for class, you gotta wait for the teacher to tell you, because it's only what, the 124th day of school. No, I made that up. But I think, yeah, it's probably right around there. I bet it's right around, I can't see. I bet it's right around there. Okay, Josh, what's the ratio of the side? Let's go small to big. Give me any ratio. Or give me any numbers. What? The angles I gave you already, 30, 60, 90. Ratio of the sides. This will be good. Ready? What's the ratio of the sides? Side. Okay, which leg is the something? Okay, let's do this one. We have a small leg, a big leg, and the hypotenuse. Remember in the triangle unit, the side, the length of the sides is related to the measure of the angles. Largest angle is opposite the largest side, verse versa. Smallest side is opposite the smallest angle, verse versa, right? Verse versa, is that funny, right? Because I'm funny. Okay, yeah. What are we doing here? We'll go back. We're gonna. Well, you guys each had a chance, right? Hold on. Let's try Kieran, and then we'll work our way back. Kieran, the smallest side. 12. You're gonna give me a number. Okay. So the smallest side is 12. That's the smaller leg. What's the larger leg? This is your problem, Kieran. What the heck? Kieran? No. This is the smallest side. How is this side bigger in 6? Okay, you wanted to make the bigger side 12. So now you're making a super hard problem because this is the red 3 side. So no me gusta. Let's keep your side 12, please. 12. Or did you want to make the hypotenuse 12?
24.
Okay, now we got, all right. So if the small leg is 12, the hypotenuse is 24. 12 rad 3 is the big leg. Okay, 12 rad 3. So you started with that one. To get to here, you did what? Doubled it. To get to here, you multiplied by rad 3. Okay, so what is the ratio of the sides? What if this is 1? What the? 1. Josh. Okay, 1, rad 3, and 2. Or just rad 3. That's the ratio of the sides. Now, we also did this the other day where we had just drew the triangle, and I can draw it any way I want, right? If we go this way, 60, 30, x, if that's x, then this one is x rad 3, and this one is 2x. Okay, what's up? What don't you understand? That's just the ratio of the sides. You know how in a 3, this could be 5, this could be 12, this could be 13. Those are all in the ratio.
Where did you get 2, 1, and rad 3 from?
We did it. What, were you in class yesterday? Oh, I forgot you were sleeping in class yesterday.
Okay, well, like that's irrelevant. I'm actually trying to pay attention.
Yeah, but yesterday we explained where it came from. I can't teach the whole lesson yesterday. Go to Dominate Math with Mr. Soko and watch the lesson. You'll actually see me waking you up during class. Am I being a jerk?
Yeah.
Oh.
You kicked my pencil pouch yesterday.
Yeah, I kicked it all the way over there.
Yeah,
So you remember that, but you don't remember why this works.
That was
So yesterday, just a quick overview of what we did yesterday. I gave an equilateral triangle. I gave you this side. Okay, once we knew that side, this was the altitude. We knew that this was half of it because it divides this in half. Look, 1 is half of 2. And then we knew this and we knew this. Then we did the Pythagorean Theorem. A squared plus B squared equals C squared. We did all that. So we punched in this number, we punched in this number, and what had happened every single time is that this ended up with whatever this was, rad 3.
Yeah, but you didn't have one of the numbers up there. You were just like, give me a number.
Right, because it's always the same ratio. Just like this. All of these are in the same ratio. Everything here will be a factor of that. 5 times 2, 13 times 2, 12 times 2. This would be 5 times 5, 13 times 5, 12 times 5. Well, this one here would be 1 times 5, if it's a 5, 2 times 5, which would be 10, and 5 rad 3. So whatever we're multiplying by is the same thing.
What? Wait.
This is
Hold
pretty.
on, do it one more time.
Nope.
So,
Okay. Got it? What? It's pretty good.
please, I want to see the guy.
Nope. I was watching like the Radio Row, like NFL, right? And they had Justin Jefferson on. You know who he is? He's the guy that does it when he scores the touchdown.
What the heck was that?
Are you making fun of my dancing?
No, it's really not good. Wait, what's it called?
We ready? I'm exhausted now. That was tiring. So that's the ratio of the sides. Now we also came up with another triangle, and that triangle was a Thank you, Ramesa. Somebody raised their hand. Somebody paid attention yesterday. Go ahead. An isosceles right triangle. And in an isosceles right triangle, oh my God. In an isosceles right triangle, what are the measures of the angles? In an isosceles right triangle, Kelsey. The same ratio? Oh, the 2 legs are the same. Okay, yeah. But then my question first is, what are the measures of the angles? Yeah, okay, yeah, because they all have to add to 180. We talked about it. So yesterday, 45, 45. It's an isosceles right triangle, 45, 45, 90. If it's isosceles, correct. The 2 legs are the same. So are you giving me a ratio? 10 and 10. 10, 10. You can do the Pythagorean Theorem, or if you remember what we came up with every time yesterday, whatever this was, whatever this was whatever this was. Alex?
10 rad 2.
10 rad 2 times rad 2.
Oh, never mind.
10 squared plus 10 squared equals c squared. If you do the whole Pythagorean theorem, you end up with 10 rad 2. 10 squared, and it happens no matter what you plug in. We end up with 200 equals c squared. C equals the square root of 200, which is the square root of 100. Square root of 2. 10 rad 2. See how much effort that took me? Instead of just being, oh yeah, you're 10 rad 2. Now you can do the Pythagorean theorem every single time. Go ahead. Except when I give you the speed quiz and I say finish this quiz in 5 minutes. What? Maybe, I don't know. Sometimes I do it. Depends how many people are sleeping during class. Or doodling. That's what I do too. Except when I doodle, my doodle sign always go like this. For some reason, I love drawing like 3-dimensional cubes. So I'll draw a cube, then I'll draw another cube like this. I'll be like, all right, so one could be over there, and then you're like, which one's sticking out? Is that one sticking out, or is that one sticking out? That's what I do. That's how I do it, right? Pretty cool, right? And then I stare at it and I amuse myself, right? Which cube is sticking out? That one or that? All right, so we have that. So if we have to put it in the same ratio as this, right? So now I'm going to put a 1 here. What's this? A 1. What's this? 1 rad 2, or just rad 2. Okay? If we did it with an x, if I put an x here, what's this? X. What's this? X rad 2. So it's the same thing in like those problems where I was like, the ratio of the sides is blank to blank to blank, and you attach an x to it. Well, the ratio of the sides is 1 to 1 to 2. So anything times that is what you're going to get in the 45, 45, 90 triangle. All right. Now, we can go through different problems then. If we go back to the 30, 60, 90. Okay. Let's use, which one do you want to use? This one? So if this was 12. Actually, that's the one we started with, isn't it? All right, if this was 4. Not everybody at once. If this is 4. That was sarcasm. Everybody at once. If this is 4.
Or rad 3.
Or rad 3. If this is 8. If this is 20. 40. Okay. If this was 60. If this was 100. If this was 10 rad 3. If this was 30 rad 3. Okay, so because they're always in the same ratio, so you could do that and quickly find those missing things. Alice.
So for that one, like the 36 and 90, it's always gonna be that 3.
Yes, that's always the ratio of the sides. Just like the one I showed you earlier, 5, 12, 13 is always the ratio of the sides. Okay, now the problem came in is when I said this was, let's see if people remember yesterday. This is 9. No one remembers? I thought someone would remember what we came up with. No. How do you get from x rad 3 to x? Or first of all, how do you get from 2x to x? How do you get from 2x to x? How do you get from 2 to 1? You divide by 2. Well, how do you get from x rad 3 to x? You divide by rad 3. But if you divide by a rad 3, you have to rationalize the denominator. We end up dividing by that rad 3 and then multiplying by 3. Which ends up multiplying by 3. Wait, what? Watch. X rad 3. To get to here, I'm going to divide by rad 3. Can you divide by rad 3? So what you do is you multiply by rad 3 over rad 3. Remember rationalizing the denominator? I feel like I taught this lesson yesterday. I did. X rad 3 times x rad 3 is 9x. Rad 3 times rad 3 is 3. What happened to my rad 3? It's not working. That just says 3x. I messed up somewhere. I messed up. Let's do it with a number. Let's make this. What did I say this number was? 9. I don't know why it didn't work with the x rad 3? I take the 9, and to get to here, I divide by rad 3. Oh, because it was an x rad 3. It was supposed to just be an x. That's why it was messed up. So to get from here to here, you divide by rad 3. Now that's the answer. You just divide by rad 3. Just like if this was 10, this is 5. But what's wrong with the answer? Can't have a radical in the denominator. So you multiply by rad 3 over rad 3. So you get 9 rad 3 over 3, which is equal to 3 rad 3. So if this was 9, this is 3 rad 3, then what's this? Thank you. Just multiply by 2. 3 rad 3 times 2 is 6 rad 3. If this is 15, what's this? Now we discovered all of this yesterday. So, and I did this problem. So instead of staring at me like this, look at your notes. Ramesa? No, this is 15. 5 rad 3, very good. If this is 5 rad 3, then this is 10 rad 3, okay? If this is 30, what's this? 10 rad 3, 20 rad 3. This is 90. 30 rad 3, 16 rad, what, 60 rad 3, right. So you divide by 3, multiply by the rad 3, okay? So we talked about that yesterday. Now, we can go to this one. If this is 5. What? Oh, no. Okay. This is 5. 8. 11 rad 2. 11. Okay. What happened when this was 10? Don't make me do all that again. I did it yesterday. I don't want to do it again. Ramesa, it's 5 rad 2. Okay, so let's see if we can remember the pattern. If this was 10, this is 5 rad 2. If this is 12, we got more people 6 rad 2. If this is 20, if this is 40, if this is 36, divide 36 by 2. I'll help you. 18 rad 2. Okay, got it now? All right. So that's one way to kind of, if you memorize that junk, whatever, it helps you find missing sides faster instead of doing the Pythagorean theorem. All right. What I wanted to do today with the lesson is let's do the same thing we did with similar triangles. Okay, I've got a triangle right here. Here's my 60-degree angle. All right, and I'm going to say this is 12. And I want you to find the missing sides. So let's say I want you to find y. What's up?
Do you post your YouTube videos like when odd period ends?
I'll post it like during homework usually. Yeah. Yesterday's lesson was a full 42 minutes. Like I taught bell to bell yesterday. I screwed around a little bit. So now let's relate it to similar triangles. Corresponding sides are proportional. So another way to solve this is set up a proportion. What side does y go with in this triangle? This triangle is similar to this triangle. So we can set up a proportion. What does y go with? Now remember when we did the similarity, we turned the triangle. Do you need me to turn the triangle? We can just do small side to small side, right? Y over 1. Y over 1 equals, what side do we know? 12. What does 12 go with? 12 over 2. Y over 1, 12 over 2. Similar triangles, just like last unit. Cross multiply. 12 equals 2y. Divide both sides by 2, y equals 6. So this is now related to similar triangles. So you can do the Pythagorean theorem, you can do the special right triangle craziness that we just did, or similar triangles, different ways to solve problems. Let's say we wanted to find z. Z over what? Rad 3 Big leg over big leg equals 12 over 2. Cross multiply. 2z equals, what's 12 times rad 3? It's 12 times rad 3. Get z by itself. Divide both sides by 2. Z equals 6 rad 3. You still get the same answers. It takes a little longer. Okay, but you're using similar triangles. So you can use similar triangles. You can use the Pythagorean theorem. You can use the memorization technique that we did earlier. Don't tell anybody that I said you're allowed to memorize stuff. Plus, you're supposed to know this stuff. Hey, what did we talk about yesterday? Did I ever tell you like how I used to do my essays in college? Like I get the prompt and I would memorize the whole essay because I couldn't write. I had like anxiety. I would go in there to write an essay and I would just blank. I'd be like, what? Like I did that when I had to take the GRE. It's like it's a class, it's a test to get into like grad school, and it's on a computer. So the prompt pops up and there's a timer in the corner. It said like 40 minutes and it just counts down. And I was like, and I'm just staring at the timer and then I read the prompt and I read the prompt, what? And then I stare at the timer and then read the prompt and then, oh my God, the timer only says 26 minutes. I haven't even started. That's what happened to me. And then finally I just was like, just started typing junk. I passed. Maybe I did better on all the other parts, but yeah. I mean, really, it's like the GRE is like, here, pay money. No, oh, shh. Mute this part. Shh. Mute. Yeah, so yeah, they do a really good job. Ready for the 45, 90? I aced the math part though. Aced. 100%.
You did?
I don't remember. Okay, let's do one with a 45, 90. Now, anybody like this way? Anybody like similar triangles? Maybe? Okay, now let's do one where we've got this. Here's my triangle. And this is 10. We already know what in this, they're trying to find W. Now, how many people already know what W is? What's W? It's 10 rad 2, right? I'm not going to be there to do this on the quiz for you. When you're taking the quiz, I'm not going to be able to do that. You're going to have to do it yourself. 10 goes with what? W goes with what? Cross multiply. W equals 10 rad 2. Okay? Let's do different. Let's do this one.
Where is 2?
What?
Why is how do we get the square root of 2 as a...
That's that side length. That's that ratio. Okay. Now, some people don't like when this is 16. And then having to find these. Do you know these? Does anybody know from what we were doing earlier? Anybody know those? Yell it out. Thank you. Remember what we did before? We got to kind of remember. All right, but if you don't know that, now we need to find P. What does P go over? P1. 16 over rad 2. Cross multiply. P times rad 2 equals 16. How do you get P by itself? Sorry, I started doing it first. Divide both sides by rad 2. P equals 16 over rad 2. Which is what? You divide by rad 2 to get to the side. Remember we talked about it? And Alice sees a problem. What's the problem? You can't have it. So he learned in 2 weeks ago how to rationalize the denominator. You get 16 rad 2 over the square root of 4, which is 2. You end up with 8 rad 2. All right, so you can either do all this work or all of the Pythagorean theorem, or you can remember the ratios and know how to move from one side to the other side. Either way, you're going to practice it right now. Okay? There's an assignment I put in Canvas called special right triangles. I think there's 10 problems. If you really know what you're doing, you can be done in those 10 problems in 48 seconds. Because I finished it in 16. So that's like the rule. Whatever the teacher finishes it in, the student should be able to do it 3 times that amount. That's like a rule of thumb.
I know, right?
Looks like you.
We used to do that. I used to work in the produce department at Dominic's, and like a box would come in. So you're always supposed to put whatever box comes in, you're supposed to put like behind the other box, right? Or you're supposed to use the stuff that was in there first. It's like first in, first out. So like I'd have a box of oranges and a whole bunch of oranges, but the old oranges were over here. So I would write on the box, look. And that, so they would know where to look. Right there. Bang. Why did I tell that story? I know. I'm weird. Oh, thank you. Oh my gosh. Oh, mess right now. All right, so you guys find it's posted, right? I put it in there? See or no?
Yeah.
It's in there? Okay, it's like 10 problems, right? I did it yesterday, so I don't remember.